Okay, take your attendance first. Huh? Okay, guys. So let's start today's lesson. Okay, you can hear me, right? Anybody? Can hear me? Anyone? Can hear me?
Yeah.
Okay. Okay, thanks. Okay, so we start with the. So today we going to do the questions at the back for gravitation. Today is going to be the last class for gravitation. Okay. Okay. So let's recall back what you learned. What you learned last class. So we're going to do these questions. Okay, before we start, okay, let's recall back what you learned about gravitation. What you learned in this topic. Can you recall back all the formulas you learned? Okay. Okay, so the first equation you learned about gravitation is what? Newton's law of gravitation said force between 2 point masses is proportional to the product of the masses and inversely proportional to the square of the distance. GMM or R squared was introduced. First formula. This going to causes all the other equations to be take form. So second, gravitational field strength. What is gravitational field strength? Force per unit mass. Oh, hold on. Let me check whether I recording it. Okay. So force per unit mass. So force per unit mass end up what equation? Gm over R squared. Then we discuss about how gravity affected altitude, latitude, and the rotation. Okay, rotation is important. And we found gravity is maximum at the surface of the Earth. Okay. And the third, after that, we learn about how satellite was launched. What are the two things needed for satellite? The height it need to be launched. So by equating Fg equals to Fc, we found that the period formula T squared equals to for Paris squared Gm R cube. This equation has been formed, and this equation helps us to find what? This equation helps us to find how high the satellite need to be launched from the center of the Earth. Center of the Earth. Okay, then orbital speed was discovered again by using Fg equals to Fc, the centripetal force of the satellite equals to the gravitational force between satellite and the Earth, and found the orbital speed is root of Gm over R. Okay, Gm over R, the orbital speed. So then after that we discuss what? After that 5, we talk about gravitational potential energy. Gravitational potential energy is defined as work done to bring a unit work done to bring a mass object from infinity to that point. What's the formula? Negative GMM over R. Okay. Then 6, we talk about gravitational potential, GP, gravitational potential. Gravitational potential is similar as gravitational potential energy, right? It just per unit mass. Work done per unit mass to bring the mass object from infinity to that point. Work done per unit mass. So negative Gm over R. Okay, 7, you have to know the gravitational potential energy is equals to the mass times gravitational potential. This how the potential energy and potential linked. And 8, finally, a very low profile, the escape speed. Escape speed, okay, it's root of 2 Gm over R. Okay, so this is what you learn. Okay, the problem here is all equations without fail as the Gm values. Everything related to Gm, G times M. Remember, Gm can be replaced with what? Can be replaced with Gr squared if mass of the planet is not given. Okay. Okay, so this is what we learned. Okay, so based on this equations, we start to do the question. Okay, we're done with the first one. Okay, now the second one. Okay, 1 minute for you. Read the question. Tell me which equation is the most suitable from 1 to 8. You have 1 to 8 equations here. Which equation is most suitable? I want you to get that equation to me. Okay, you can work out the answer. Good. Number 2, 1 minute for you. Read the question. Find the period of revolution of a satellite moving in a circular orbit around the Earth, Earth at a height of 3.6 times 10 power 6 meter. The height, be careful, make sure, is it from the center of the Earth or from the surface of the Earth? This is the trap normally. So the circular orbit around the Earth at a height of 3, this height, that's not center of the Earth, from the surface of the Earth is 3.6 times 10 power 6 meter above the Earth's surface. Assuming the Earth is in a uniform sphere, radius of this, the Earth mass is this, G is this. So find the period of the revolution of the satellite. So which equation is the best to be used? 1 to 8. Okay, I give you 1 minute. Identify which equation is most suitable to work out. Okay, Daniel, yeah. Daniel, which equation do you think?
T square equals to 4 pi square over
Very good.
GM R.
Yes, good. The third equation, right? T squared. The set period, right? So only formula with period is the third one. T squared. Okay, now you have to realize. Okay, so 4 pi squared GM R cube. M mass. This mass of what? Mass of the satellite or mass of the planet? Mass of the satellite or mass of the planet? Anybody? So this should be Jantat, yeah? Jantat. This mass of satellite or mass of the planet?
Mass of the planet.
Mass of the planet. Okay. R how much? Yeah, Jantat can continue. What R how much?
The radius plus the height.
Very good. The radius plus the height. Radius plus the height. Be careful. Okay, yeah, it's good. So the third equation to be used, the mass is the mass of the planet, and the R is the both R add up. Okay, the R will be, they try to trick you with the R, as I said. Sometimes they give from the center to the satellite. Sometimes they give just the height. If they give height, must add the radius. Okay. So, and another one thing, of course, check all the units are unit SI units. So in this case, all SI unit. Planetary normally is be SI unit. So you should get 9,910 seconds. Okay. So the equation to be used for the second one is the third equation. It's used. Okay, 1 minute for you. Come on, get the working. Hope you get 9910 seconds. Okay, those who done with 2, get your working. Now go ahead with number 3. Read the question, try to figure out which equation do you think should be suitable. Sometimes maybe more than one equation needed. If you can do, you identify which equation, just try to get the work out. Try to get the answer at the side. Okay, those who done with 2. Okay, good. So, okay, 3. Okay, 3 is little not really clear with this equation. It's hiding, the working is somehow rather linked to which equation you think indirectly. Question 3. Okay, let's just understand the question 3 first. Calculate the least kinetic energy which must be given to a mass of 2000 kilogram at the Earth's surface for the mass to reach a point a distance of r0 from the center of the Earth. Okay, do you understand the question? Okay, let me open up the whiteboard. Clear this. Okay, maybe I put it here. Okay, so what they said is, okay, so they said from the planet, they said, what is the least kinetic energy? You want to throw an object up, okay? What kinetic energy the body should possess, how much the kinetic energy it should possess, so that from the surface, it can reach one particular point, which is R0, R0 away from what? From the center of the Earth. It means from the center to that point is R0. Okay, is R0. Of course, from the center to the Earth's surface is the radius of the Earth. In this case, is the value given R. Okay. What is the kinetic energy the particle needed so that it can reach that point? This looks like last time AS, right? Okay, AS. What is the kinetic energy required to reach a certain height, let's say 5 meters from the surface? Similar, right? Okay, so how do you find in AS? So you see the kinetic energy required equals to the gain in potential energy, right? Okay, EK equals to EP, right? Okay, so same thing should be done here, right? The how do you write it? How do you write it? How you should write it is the change the change in kinetic energy must be equals to the change in the potential energy. Okay, the change in kinetic energy must be the change in potential energy. Okay, so if you can use this format, and change in kinetic energy is change in potential energy. In this case, potential energy, we didn't put EP, we just put U, changes of U, gravitation potential energy. So changes in kinetic energy, we put, normally we put final minus initial, but if you write this term, changes of EK plus equals to changes of U. That means we are trying to make the changes of EK and changes of U as positive. The value must be positive both sides. Okay. So what you do? You put final EK minus initial EK or initial EK minus final EK. Which kinetic energy is greater? Initial greater or final greater? Final is 0, right? Final kinetic energy is 0, right? Because finally it stops, right? And when it comes to R0, it stops. So final EK is 0. But we want to make both sides as positive. If you use this method, changes of EK equals changes of potential energy, we want to make that 2 like positive. So here you need to put big value minus small always. So in this case, for changes in EK, you have to put actually initial minus the final, because initial is greater. So we want to make this value as positive. Initial minus final is equals to the potential energy. The changes in potential energy. You put final minus initial or initial minus final for the potential energy. Final minus initial or initial minus final. Which potential energy is greater? We want to make these changes positive. Final greater or initial greater? Final potential energy greater or initial potential energy greater? Okay. Anyone? Okay, Janyon here. Janyon, final greater or initial greater?
Final is greater.
Final is greater, right? Final is less negative. Final. So here you put final minus initial. Okay, initial. So we put like this. We want to make both positive. So this is the working. Okay. So initial potential energy is how much? Initial kinetic energy is half mv squared. So we're looking for this v. And now potential energy, final potential energy, initial potential energy. You know what is the formula to be used? Potential energy, what formula to be used? Which formula to be used for potential energy? Which equation? So 5, right? Equation 5. Negative GMM over R. Okay. So what do you do? Sorry. So what do you do? So right here. Okay. So what do you do? Half mv squared equals to U final is negative GMM over the final R minus negative GMM over the initial R. The initial as a phase. Okay, now let's use their term. Okay, we are looking for what? We are looking for what is the calculate the least kinetic energy. You are looking for kinetic energy. Okay, so looking for kinetic energy. So the least kinetic energy, the initial. So we don't need to expand this half m squared. Just leave it as the kinetic energy. Is this? So negative GMM. So this is going to become RF is how much? RF is R0. Oh, RF is the final. So it should be R0, right? It should be R0 negative GMM. This is going to be plus GMM over this R. R initial is what? R initial is the radius of the Earth, right? The radius of the Earth. Okay. So negative GMM. Okay. So we rearrange this. It's going to be on GMM over R. We bring it in front minus GMM over R0. Okay. The equation tend to become like this. Okay. That's the answer. What's the answer? Or they put in numbers, right? So 1.3 times 10 power of 11. Do you get 1.3 times 10 power of 11 for this? Check. Okay, look at the check. Do you get 1.3 times 10 power of 11? GMM over R. G is a gravitational constant. Okay, get the number. G is 6.7 times 10 power negative 11. M 6 times 10 power 24. and another m, mass of the, that's the object given, or 2000 kilograms, small m, and r is given. So you should get 1.3 times 10 to the power of 11 minus 8 times 10 to the power of 17. How do you get 8? Which going to give you 8 times 10 to the power of 17? The GMM. The GMM should get 8 times 10 to the power of 17. Okay, please get the working. You get this answer. 2 minutes for you to get the working. Okay, any part you don't understand? Anybody? So remember, I expand this first lah. You take down, Okay. So remember, changes in kinetic energy is changes in potential energy as your AS, gravitational potential energy. But the gravitational potential energy change, we never use MGH for planetary system, because as I told you, MGH is just an approximate value. If the R is very high, we have to use the original gravitational potential energy formula. So U final minus U initial. But when you use changes of EK equals to changes of U, we want to make both numbers as positive. So what minus what? Not always final minus initial. You have to check. For EK, I think initial greater than the final, so initial minus final. For changes of U, final minus initial, must make the arrangement so that both are positive. Okay, then you get the answer. Okay, so U final negative GMM or R. So the equation is the equation 5 to be used. Okay, get the concept. The main concept I want you to learn is which formula to be used, how to start with. Changes in EK equals to changes of U. Is it come to your mind when you read this question? Do you this part, do you know that we must arrange like both sides is positive? Okay. Then next, do you realize for the gravitational potential energy must use negative GMM over R? And RF, do you know RF is R naught? Should be the from the center to the final point. And the R initial is the radius of the Earth. Okay, so minus. Okay, so all of you got this answer? Anyone didn't get answer? Anyone got problem? Okay, give you 1 minute, come on. Get the final answer, get the working. Okay. Okay, so any questions, guys, about number 3? No questions, Okay, so now if you're done with 3, let's go to another one. Okay, 4. Okay, read question 4. Try to tell me which equation is most suitable. How do you go about to get the answer for 4? One minute for you to read and understand which equation. Okay, so I just want the equation to be familiar. Okay, good. Okay, so all of you already read the question, already understand the question. Okay, a preliminary stage of spacecraft Apollo journey to the moon was to place in an Earth parking orbit. In an Earth parking orbit spacecraft. This orbit was circular, maintained like a satellite parking orbit. It's 1 to row. So this orbit was circular, maintaining almost a constant distance about 189 km from the Earth surface, assuming the gravity field strength is 9.4 Newton per kg at that height. At that height, the small g is found to be 9.4 at that height. About 189 km away from the Earth's surface, the small g is found to be 9.4. Okay. So what do you want? Calculate the speed of the spacecraft in this orbit. What is the speed of the spacecraft on this orbit? That means the spacecraft just moving with that certain speed, like satellite. Satellite once launched, I think this spacecraft, it was when it get into that speed, it shut down its fuel. The thrust is just shut down after you reach this speed, because after you reach that speed, the Earth gravitational field will make it to move in a circular path. The centripetal force equals to the gravitational force, like satellite. Okay, do satellite required fuel? Satellite not required fuel. The satellite, once we launch with the orbital speed, that's it. The satellite will stay in that orbit due to the gravitational force, the Fg equals to Fc. So they're asking the orbital speed of this spacecraft. So remember, the spacecraft here is not continuously having the thrust. Once it attains the speed, the thrust of the spacecraft has been shut down, so that the spacecraft just move around in a circular path over there. Okay, yeah. Okay, so how to get this speed? Which equation is suitable? Anyone? Okay, Riyad, yeah, Riyad.
Yes, sir.
What do you think? Which equation?
I'm not sure, sir.
Not sure. Ashley?
The fourth.
Fourth one. Yeah, the fourth one. It's the orbital speed one. Fourth one is Fg equals to Fc, root of Gm over R. This is the orbital speed for a satellite, for any spacecraft want to go in a circular path. So the gravitational force of the spacecraft must be equals to the centripetal force of the satellite. So root of Gm over R will give you the orbital speed. But now the thing is, the spacecraft, do you know this information? Do you know the mass of the planet? This is mass of the satellite or mass of the planet? You see, any equation with only one single mass available there, that mass should be the mass, the center mass, the mass of the planet normally. So in this case is the mass of the planet, which is the Earth. Do you know mass of the planet here? Mass of the planet is not provided. The R, is it provided? The R is from the center of the Earth to the point where the spacecraft is orbiting. Do you know the R? You know the distance is 189 km from the Earth's surface. You know radius given. Radius of the Earth not given. Yeah, given. So you have to use the radius of the Earth here. Radius of the Earth, please use for part A too. Part A. Radius of the Earth is 6,370. So R given, but mass of the planet not given. So what do you do? What I told you to do? You have to use this substitution. The Gm can be replaced with gr squared. Gm can be replaced with gr squared. So the fourth equation can be changed to what? The V equals to root of the Gm can be replaced with gr squared. So R. So the orbital speed again take another new form, which is what? Gr, root of gr. Yeah, gr. So V is gr squared over R. Okay, gr squared over R, so root of gr. So what is the G here? The G is the 9.4. Okay, 9.4, 9.4, and the R is at what height the G become 9.4? The R, not to say height. What R from the center of the Earth to that point? What R it become 9.4? So how do you get this R? Which is your R here? The radius of the Earth plus with what? Plus with 189 kilometer. And these two values need to be added for your R. And another problem, kilometer change to meter. Kilometer change to meter. G is 9.4. 9.4 is Newton per kg. SI units, fine. Then you should be able to get 7,852. You get the working now? For A. Okay. Any questions, guys, for A? The equation must come to your mind is equation for orbital speed, and GM, mass of the planet not given, and mass of the planet not given. Remember what I told you, the GM can be replaced with GR squared. The gravity at a certain height given, and the R of that height, the R from the center of the Earth to that point can be replaced with GR squared. GR squared. So 7852. Okay, all of you got 7852 for A?
I get a slightly different answer.
What is your answer?
7738.
7738. The others getting 7738.
I got 7852.
7852. Okay, root of GR, right? So 9.4 times 6370 plus 189, right? Okay, let's see. So orbitals, oh, sorry. Okay, so V equals to okay, so V equals to root of GR. So G is 9.4 times R. R, you put what? 6370 plus 189, right? Yeah, 189 times 10 power of 3, right? Okay, so root of 9.4 times these two add. So what do you get? 6370. So actually, do you still get the same answer?
I made a careless mistake.
Okay, so that's your 4A. Okay, those who got the equation 4, identify the equation should be 4. And those who are identified GM need to be replaced with GR squared. Okay, good. So you got the idea. Okay, now go for 4B now. Okay, 4B. The time to complete one orbit. What is the time taken for this spacecraft to make one orbit? One complete orbit. So it's period, right? So period, which formula to be used? Of course, the only period formula is this equation. T squared equals to, is it enough information to find the period? 4 pi squared, okay, no problem. GM, you know, we can replace with GR squared, no problem. And yeah, correct. So you got the equation is 3, right? So equation should be the third one. And the GM, please replace with GR squared. Okay, so this formula again, change to what? Okay, so it's going to be 4 pi squared. Down here going to be GR squared, here R cube. So r squared, r cubed is cancel. So 4 pi squared r over g. You get the period squared. Period squared. So square root it, you get the period. So you should get 5250 seconds. You get the working? 2 minutes for you. So those who identify the equation must be third one. Good. And those who identify GM need to be replaced with GR squared. Okay, that's another one. Then another problem is make sure kilometer change to meter. Okay, any problem? Those everyone got the answer? 5250 seconds. Okay, so let's proceed. Those who done with 4. Okay, proceed with 5. Okay. Last question. A satellite of mass 66 kilogram is in orbit around the Earth at a distance of 5.7 r above its surface. Remember, 5.7 r is above the Earth's surface, not from the center, from the above the Earth's surface. 5.7 r. R is the radius of the Earth. Where r is the value of the mean radius of the Earth. If the gravitational field strength at the Earth's surface is 9.8, calculate the centripetal force acting on the satellite. Calculate the centripetal force acting on the satellite, which was placed at 5.7 r. Assuming the Earth mean radius is 6,400 kilometer, Earth mean radius. Calculate the period of the satellite in orbit in hours. You should get these two answers. Okay, class. So this is going to be your exercise. You can see like a quiz. Okay. I want you to get working for this and WhatsApp me. Okay, now it's 11:41. So about another 15 minutes. Okay, I give 15 minutes for you. Okay, before 12. Please get the working for this and WhatsApp me. All of you. Everyone. Okay. So think which equation to be used and try to figure out. Because we did a lots of questions together, I advise you how to use. So now just checking how you can do question 5. Which equation to be used, how to go about. Okay. So please send the working for me before 12. Number 5. Any questions? No questions. Okay, so I stop here. I just want the working for this.
Sir,
Send to me on WhatsApp. Yeah.
I heard we're having practical classes again.
Again?
We're having
Yeah.
practical classes again. Is it?
Classes.
Yeah, physically.
Oh yeah, physical class. The management, we are just still under discussion. I think most probably at 11th August. 11th August we will be your practical. Start with practical first, but the physical classes I'm not sure yet. But first they are trying to have the practical first. 11th August, starting on 11th August. Okay, Riyad.
Okay, sir.
The Physical classes, not sure, but practical, start with practical first. The practical also, they plan to have on Wednesday, and another slot will fall on Saturday, So you have to come to college on Saturday. Do you receive any information from the college or not?
It's in the portal. It said that we're gonna come back on 9th August.
Oh, they said all the online classes will be changed to face-to-face.
No, just for practical lessons.
Only for practical lessons. So you start with 11 August for your Wednesday. Okay, guys, so get the working for me. WhatsApp me. Any other questions? Okay, no questions, Okay, those who don't have this question, you can get it from the what do you call? From the times, or you take a snapshot this question and send me the working. Okay. Okay, any questions? No questions, Okay, I'll stop here. So spend time to get the answer for this, Okay. Thanks. So those who don't have question, you can take a snapshot. I'll give you a minute. Okay, you go to the word file for gravitation, go drag down, you'll see these questions. Okay, guys, so I stop here. Thanks. So all of you already take the snapshot, Okay, thanks.
Thank you,
Okay,
Chair.
please, yeah.
Thanks, sir.
Thank you. Thanks, yeah. So please send me the working, please, everyone. WhatsApp me.